Alright, welcome to lecture 2, definitions of GIS. One of the most difficult things for new GIS students, as well as for experienced GIS practitioners, is to come up with a concise definition of what exactly GIS is. After all, GIS is used for many different applications in dozens of different industries. GIS has a single body, spatial data storage, and many heads applications, each of which is a different way to make use of stored spatial data. In GIS, we separate the storage of spatial data from the display of the data, and in between we insert the analytical power of the computer. Because the computer can make use of different softwares, many different things can be done with the spatial data. The only limits are imposed by the nature of the spatial data, the sophistication of the computer software, and the speed of the system on which the software runs. It is not surprising that GIS is a dynamic field of study where there is always something new to learn. This is the nature of the definitions of GIS. Some definitions are very specific, while others are very general. The following 5 definitions of GIS all help to explain what GIS is, yet none succeed at being detailed, while at the same time providing a good overall picture. GIS is seen in a map view, where GIS is a storage and display device for electronic maps. The functional view, where GIS is a set of computer hardware components. The geoprocessing view, where GIS is a software toolbox. The database view, where GIS is a software for storing and retrieving spatial data. The system view, where GIS is composed of hardware, software, people, data, procedures, and applications. The map view of GIS is the most popular amongst new users of GIS. This view is popular because it allows people to build on what they already know, which is maps, and use this to understand a new technology. In the map view, the GIS can be considered to be a very fancy electronic storage cabinet for maps. In the storage cabinet, there are many interesting maps that can be examined. Not only are these maps viewable as static documents, but they can also be displayed dynamically, showing 3-dimensional or time series views of the data. GIS offers a number of sophisticated ways of viewing maps in the map view. Users are able to zoom in, zoom out, and pan to view different portions of the map. Different thematic maps layers can be turned on or turned off, and this can be displayed using a variety of cartographic symbols. In addition, the unsymbolized data can be queried directly to determine the data values that were used to create the symbolized maps. In the functional view, GIS is basically a computer. This view, which is favored by computer technicians, views the GIS as a series of computer network or components. In the functional view, the GIS has a component to perform the following task: imputing data using keyboards, digitizers, scanners, data collection computers; processing data, a computer having sufficient memory and processing speed software; outputting data, computer monitors, printer, plotters. With a functional view, we gain an understanding of the machinery on which a GIS runs. The geoprocessing view of GIS looks at the computer as a software toolbox. Just as the functional view is overly focused on the computer hardware, the geoprocessing view is overly focused on the software. In the geoprocessing view, the GIS is a repository of unprocessed spatial data awaiting analysis. Through the clever use of software tools and linkages between these tools, the GIS operator can create a process to convert the unprocessed spatial data into a desired result. This view focuses on the steps that are necessary to transform raw data into useful information. While the geoprocessing view is an effective description of the way some experienced GIS operator works, and it describes the way that many consultants use GIS in reality. We have the database view. The database system in which most of the data are spatially indexed and upon which a set of procedures operated in order to answer queries about spatial entities in the database. Because the database view focuses on the storage of spatial data, it places a strong emphasis on the quality of the data. Above all, data are something that should be reused. If possible, poorly structured or poorly documented data are difficult to reuse and should be avoided. Thus, people holding this view expend a great deal of energy keeping a clean database. GIS data should have the following characteristics. 1. They should be simple to use and easy to understand. 2. They should be easy to use with other data sets. 3. They should be effectively compiled and validated. And 4. They should be clearly documented for content, intended use, and purposes. We move on to the system view of GIS. The system view of GIS is a holistic but sophisticated look at GIS. In the system view, a GIS has the following components: has the hardware, the software, people, data, procedures, and applications. The system view incorporates the functional geoprocessing and database views of GIS and recognizes the importance of computer hardware, software, and spatial data. However, this view also recognizes that GIS never exists in a vacuum. We have the database view. Now, the database view, in which most of the data are spatially indexed and upon which a set of procedures operated in order to answer queries about spatial entities in the database. Because database view focuses on the storage of spatial data, it places a strong emphasis on the quality of the data. Above all, the data are something that should be reused, if possible. Poorly structured or poorly documented data are difficult to reuse and should be avoided. Thus, people holding this view expend a great deal of energy keeping a clean database. GIS data should have the following characteristics, which of course we say should be simple, should be easy to use, should be effectively compiled and validated, and should be clearly documented for content, intended use, and purposes. Now we have the definitions of GIS according to the following people. According to Doe in 1987, 137, GIS is defined as a system of capturing, storing, checking, manipulating, analyzing, and displaying data which are spatially referenced to the Earth. Arnohoff in 1989 defined GIS as any manual or computer-based set of procedures used to store and manipulate geographically referenced data. Carter in 1989 defined GIS as an institutional entity reflecting on an organization structure that integrates technology with a database, expertise, and continuing financial support over time. Parker in 1988 defined GIS as an information technology which stores, analyzes, and displays both spatial and non-spatial data. Dwecker in 1979 defined GIS as a special case of information systems where the database consists of observations on spatially distributed features, activities, or events which are definable in space as points, lines, and area. A GIS manipulates data about these points, line, and area which retrieve data for hard queries and analysis. Smith et al. in 1987 defined GIS as a database system in which most of the data are spatially indexed and upon which a set of procedures operated in order to answer queries about spatial entities in the database. Jose Morris Smith and Sicherman in 1981 defined GIS as an automated set of functions that provides professionals with advanced capabilities for storage, retrieval, manipulation, and display of geographical located data. Burrow in 1986 defined GIS as a powerful set of tools for collecting, storing, retrieving at will, transforming, and displaying spatially referenced data from the real world. Cohen in 1988 defined GIS as a decision support system involving integration of spatially referenced data in a problem-solving environment. Koshakirov, Tukhonov, and Trofimov in 1989 defined GIS as a system with advanced geomodeling capabilities. And Devine and Field in 1986 defined GIS as a form of management information system that allows map display of the general information. And so we've been able to go over what the definitions of GIS in lecture 2, and here we can see GIS has been defined by different individuals and has been defined in different methods to suit the purpose of which GIS is used for. Thank you.